So in this last lesson on factoring, this is our last factoring lesson this unit, we're doing perfect cubes and also practice with what we've learned. So this pattern for perfect cubes is not completely obvious. We're going to show that it works, basically, but after that, you're kind of just going to end up having to memorize how to factor these. The other ones are a little more intuitive or some sort of process to follow. This one is really a formula. So here, to start to get to that, it says, just as there is a pattern for factoring the difference of perfect squares, there are formulas for factoring the sum and the difference of perfect cubes. So whereas perfect squares only works when the two terms are subtracted, perfect cubes, which we can see down here, work when it's adding or subtracting. So we're actually going to start, here's two identities, and these identities are going to allow us to factor, but we're going to confirm this first identity. We're going to multiply this out, and that's what we're doing up here, just to show that it actually, if we multiplied factors out, would equal the a cubed plus b cubed. So I'm going to triple distribute here. So we have a cubed minus a squared b, and we did this in Unit 1, this type of problem. You just didn't know it was related to factoring at that time, plus ab squared. So that's my first three distributions. And then we're going to do the next ones. So I have plus a squared b, and then minus ab squared, and finally plus b cubed. So from here, if I put in ones, that might be necessary, but this one pretty clearly, like these two terms are going to cancel, right? And these two terms are going to cancel, and we're just left with a cubed plus b cubed. So in math in general, some things that are kind of simple we can think through in our heads each time. For this one, if I really look at the structure of this expression, I can go through, if I can hold enough in my head, I can see, yeah, why that would equal a cubed plus b cubed, but that's kind of hard to do every time. So ultimately, these are our formulas we use down here. Now, another basic skill you'll need for perfect cube is actually to know what those perfect cubes are. So this list of numbers here is our perfect cubes. I'm going to circle the ones that you probably want to know. Okay, probably down to here, like those are the main ones we use. So these are perfect cubes because 1 times 1 times 1 is 1, 2 times 2 times 2 is 8, and so on. So if I was going to take a cube root, which is basically not a square root, we put a little 3 there and that means a cube root. For example, the cube root of 64, that means what number times itself 3 times is 64, and that number is 4. So when I'm trying to look at something like this and recognize, oh, is that a perfect cube? I really need to know that I'm looking for 1, 8, 27, 64, 125, or 216, possibly the other ones, but they don't show up as much. For variables, we are looking for the variable to be divisible by 3. So if I have an expression with x to the 6th, that works, right? Because 6 is divisible by 3. If I have an expression with x to the 5th or x to the 4th, that's not going to work because those exponents to be perfect cubes have to be divisible by 3. So I'm going to move this down now and we'll start to look at some examples. Now, because this one is not as intuitive as the other ones we've done, it kind of helps to start out by first identifying our a and b values. So first off, I look at this expression, x cubed minus 8. That's in the form like this, a cubed minus b cubed, because 8's a perfect cube and x cubed is a perfect cube, and they are connected by subtraction. So in order to plug them into this formula to factor, I need to figure out, well, what is cubed? And you can do this in your head, but I'm going to write it on the side. So from my x cubed, that's just x, right? X is cubed is x cubed. From my 8, and I don't look at the negative sign, that just picks the formula for me. I just think of positive 8. So if I go back and I look at my list, right, 8 is 2 cubed. Okay, so here's that problem right there. And I wanted to switch to a pen, right? 2 cubed. So 2 is my b value. Sorry, this is not super smooth. No. Okay. So somehow I pushed a button and now all my stuff is connected. My writing is no longer connected. So I'm going to try to fix this. So I got an X. Okay, I guess my writing is just there. At least I'm going to have to erase some stuff. And then when I move it. So you can forward if you want to. This shouldn't take me too long. We got some moving writing. Let's see if that's enough. Okay. And we'll erase some more. Something popped up when I pushed the wrong button and it made the writing, like as I said, kind of like its own picture. So I have to erase it all. Okay, so back to what we were talking about. Push the pen. Okay, so looking at this, my A value, what is cubed, we said was X. And my B value, what's cubed here, is a 2. So once I identify those, I'm just putting them into this formula. For the first time, I'm actually going to write down the formula so I can plug them in and really see what's happening, but I don't have to write it every time. So A minus B is going to be A is X and B is 2. A squared is going to be X squared. AB, right, is X2, but we write that as 2X. And then B squared is 4, okay? Now, something about these, with this structure of A squared plus AB plus B squared, this trinomial will not factor in the way we learned last lesson. Okay, so there we can check. There's no numbers that add up to 2 and multiply to 4, right? There's nothing that works, so that is done at that point. So let's look at our next one. Our next one is in the form A cubed plus B cubed. So we're going to use this formula this time, right? So what is cubed in this first term? Well, the cube root of 27, the number times itself 3 times, that's 27, is 3. And then we also need an X for that first term. 1 cubed is 1, so the B value is just 1. So I'm going to try to look at the formula this time and just kind of like look at it and fill stuff in. So for A plus B, I need 3x plus 1. For A squared minus AB plus B squared, it's a little tricky here. This is usually a spot where people mess up. If I take this and square it, 3x times 3x is 9x squared. Make sure you have the 9 and don't just leave it a 3. Multiplying them together is subtraction, so 3x times 1 is 3x, and we have to subtract it because it's minus AB. And then b squared is 1 squared, so I just have 1. Okay, once again, trinomial does not factor further, so that's where we stop. So let's look at the bottom two. And actually, I don't want to move it up too much because I still want to see my formulas. So we're going to do this next one. So here, my first term has an x and a y, but since they're both perfect cubes, what's cubed is just xy, right? If I divide those exponents by 3, I get 1, or x to the first, y to the first. My b value is 4. 4 cubed is 64. So I look up my formula, and that's the a cubed minus b cubed formula. So a minus b, right, will be xy minus 4. This is a little tricky here for a squared. I want to square this, so I get x squared, y squared. Putting them together is going to be 4xy. And at the end, 4 squared is 16. Okay, so that is my answer to that one. The next one, this is the first time where we don't have x cubed, right? So just once again, you're going to see these mixed in with other factoring pretty soon. We're looking for both terms are perfect cubes, 2 terms, and connected by either addition or subtraction. So that's true here on this one. Let's see, back for this one. So A, 125 is 5 cubed, and you can look up at the chart. X to the 6th, 6 divided by 3 is 2. So the first term is 5x squared, and the second term is 2. So a plus b, and one thing that helps you remember it, if you look at your two formulas, do you see how this a plus b has the same sign as the a cubed plus b cubed, and this a minus b has the same sign as the a cubed minus b cubed. So that is like the first thing I always know because you have to memorize these formulas. And then here, a squared and b squared are always positive, right, no matter what. And then this sign is the opposite. So if this is plus, this sign is minus. If this sign is minus on the original, this sign is plus. Otherwise, the formulas are basically the same. So because this is a positive, I know here I'm going to have 5x squared plus 2. Over here, a squared, if I square this, it's going to be 25x to the 4th. Okay, multiply them together. Now here the sign is opposite of what I started with, so that's minus 10x squared. And then b squared at the end is just 4. So that's your difference of pure perfect cubes. We have a couple more on the next page.